Hi, this is Dr. Gulshan Sahani, and today we are going to talk about the Einstein special theory of relativity. Well, Einstein got a Nobel Prize, and he's better known for theory of relativity, but the Nobel Prize was given to Einstein for his work on photoelectric effect. Now, let's talk about this problem, which is primarily a length contraction problem. Here, L is the length, which is moving length. L naught is called the proper length or the length at rest. And this under root of 1 minus v square by c square is denoted by gamma, is called as Lorentz factor or Lorentz function. Now, let's talk about the moving length and the rest length. L0 is the length measured in a stationary frame of reference, and L is the length measured from a moving frame of reference. So what is the difference between the two? If you are sitting in an aircraft and you are holding a meter rod in your hand, then its length is L0, that is the proper length or length at rest. But if a person is outside the spacecraft and observing that 1 meter rod in your hand, then that person will get the length as slightly shorter. Why? Because this vector, which is gamma, is 1 minus v square by c square, where v is the speed with which, the relative speed with which it's moving, and c is the speed of light. So this vector is having maximum value as 1, but for any value of v, it will be having value less than 1. So gamma is maximum 1, but it is less than 1 because of any speed for a moving object. So in this particular case, a Tate Federation spacecraft flies past a planet, Naboo, at a speed of 0.69 times c, that is c is the speed of light, and a scientist on Naboo measures the length of the moving spacecraft to be 78 meters. So this is the moving length, right? Later, the spacecraft lands on Naboo, ready to invade, and the same scientists again measure the length of the new station. So what we are giving is a moving length, yeah, that is L. And what you have to find is what will be the length when it is stationary. So we are interested in finding the length at rest, or length of the spacecraft measured by an observer who is at rest. Now, let's plug in the values. We are interested in finding the value of L0 or L0, which will be L divided by the value of gamma. And if you work out the value of gamma by plugging in value of V as 0.69c, then the value of this gamma works out to be 0.7238. So if I plug in the value of gamma in this expression, I get rest length equal to the moving length divided by 0.7238. And if I divide the moving length, which is 78 meters, by 0.7238, I get the answer as 107.64 meters. That is the length at rest. Now, remember one thing in mind here, that was the difference between moving length and stationary length. When you are in a spacecraft, your rod in your hand or any mark inside the aircraft is stationary with respect to you, and therefore that is a proper length or L naught. But if the same is being observed from a person who is standing outside, with respect to whom this spacecraft is moving, then that person will observe the length as shortened length. That's called length contraction. In this case, we are given the contracted length. That is, when the spacecraft is moving, then the length is 78 meters. Okay. And we have to find out what will be the length at rest. So it's a reverse problem. It is length contraction when you observe it in a moving spacecraft, but then it is length elongation when you're observing it otherwise. So here, in this case, the length at rest would be 107.64 and length moving is 78 meters. So the answer is 107.64 meters, which is the length observed as the rest length. Thank you. I hope this should work. And if you have any other questions regarding Einstein special theory of relativity, say time dilation and mass increase, the rest mass and the moving mass, I am ready to answer them. Thank you all very much. Thank you.